Section 5, Oligopoly. Here are the characteristics which have been taken from the curriculum. The most significant characteristic of an oligopoly market is that there are a small number of sellers who dominate the market. The products offered by each seller are close substitutes for the products offered by the other firms. These products may be differentiated by brand. For example, if you take Coke and Pepsi, the products are differentiated by the brand. It is also possible that the products offered by the different firms in an oligopoly market are homogeneous and unbranded. Entry into the market is difficult. In other words, barriers to entry are relatively high, which would explain why we have a relatively small number of players. Firms typically have substantial pricing power. Products are differentiated through marketing. So marketing, advertising is often important. And if there is differentiation, the differentiation happens through marketing as well as various features the product might have and non-price strategies. Note that this is not critical, however, for a given market to be considered an oligopoly. It is also possible to have an oligopoly where we have 2 or 3 firms producing products which are not differentiated. Another important aspect of an oligopoly is that there is temptation to collude. If you have 3 firms in a given market and these 3 firms have pricing power, it is possible that they decide to form what's called a cartel and collude in order to set a high price. We'll talk more about this later. Demand analysis and pricing strategies in oligopoly markets. At a high level, there are 2 possibilities. Possibility 1 is that the firms in an oligopoly market collude. The other possibility is that they do not collude. If the firms do collude, then there will be a certain market demand. So this is the overall market demand, and the firms in the oligopoly agree on how they will divide this particular demand. And if the firms can do this, then they can set the same price that a monopoly would be able to set. If firms do not collude, then each firm faces an individual demand curve, and the market demand curve will depend on the pricing strategies which are used by the various firms. In terms of pricing strategies, we'll cover 3 types: pricing interdependence, the Cournot Assumption, and Nash equilibrium. Let us consider the first strategy, which is pricing interdependence. This obviously implies that the pricing of the players in the oligopoly market will be interdependent, and this leads to what's called a kinked demand curve. The major premise here is that a competitor will not follow a price increase but will cut prices in response to a price decrease. To understand this, let's consider an example. Say in a given town we have both Coke and Pepsi. These are the only players in the cola market. So we have a kind of oligopoly here which is called a duopoly. This is where we have 2 major players. Let's consider the Coke perspective. So we have the demand curve for Coke. Assume that initially the price of a 1 liter Coke bottle is 100 rupees and the quantity is 5,000. And say we are at this point. If Coke increases its price from 100 to say 105, what will Pepsi do? According to what we see over here, Pepsi, which is the competitor, will not follow a price increase. So Pepsi is still at 100. What will most consumers do? Consumers will switch to Pepsi. So what will happen to the demand for Coke when the price is increased? The quantity demanded will decrease substantially because consumers now are moving to Pepsi. Therefore, this part of the demand curve is quite elastic. On the other hand, what if Coke decreases the price? So if Coke says that they want to reduce the price to 95, then what will happen? According to the premise that we discussed at the start of this slide, the competitor will cut prices in response to a price decrease. So now both Coke and Pepsi are for 95. What will happen to the quantity demanded? So when the price goes down to 95, the quantity demanded will increase, but not by as much because there is no substitution effect taking place. Consumers will demand a little more cola overall because it is cheaper, but consumers are not substituting Coke for Pepsi or vice versa. So this part of the demand curve to the right of the kink is less elastic. Effectively, we have two different demand schedules in this particular model. Also note that we have a discontinuous marginal revenue curve. If you have time, you can plug in some numbers and demonstrate that the marginal revenue is discontinuous. For example, you can use a situation where the price goes from 100 to 105 and the quantity falls a lot, say from 5,000 down to 3,000. You can plug in some numbers and demonstrate that the marginal revenue is discontinuous. For example, you can say when the price increases from 100 to 105, the quantity comes down from 5 down to 3,000. On the other hand, when price comes down by 5% from 100, say, down to 95, then the increase in quantity is only marginal. Say the increase in quantity goes from 5 to 5.5. You can look at the marginal revenue in this segment and the marginal revenue in this segment, and you'll notice the discontinuity. The curriculum doesn't get into the numbers, so I will not do any calculations or numerical examples over here. These points, however, are important and testable. Notice that the pricing interdependence model helps explain stable prices. So this model would explain why, for example, we have a price of 100 in this market. The 100 point is where we have the kink, and according to this model, the point where we have the kink is the stable price and quantity. But this model does not tell us how we arrive at this particular price. So keep in mind that this is the advantage, this is the disadvantage, and you also need to know how to explain the model. The next model that we look at is the Cournot assumption. The premise here is that each firm determines the profit maximizing quantity assuming other firms' output will not change. So notice that, so here we do not consider the actions of the other firm. We do not consider the fact that the other firms might change their output. You need to remember the key premise here, just as you need to remember the key premise with the pricing interdependence model. Another point related to the Cournot assumption is that in the long run, a change in price or quantity will not increase profits. So if you have two companies, A and B, in the long run, this company is producing a certain quantity Q and selling at a certain price P, then in the long run, changing P or Q will not increase the profits of A. That's why we say that A is at equilibrium. And the same holds true for B. So B also is at equilibrium. And if these two firms constitute the market, then the market is in equilibrium. Now let's just look at the price and quantity numbers associated with the Cournot assumption. If we look at the demand curve for the market, where we have price over here, quantity over here. With a monopoly, which is what we'll talk about in the next segment, we have a relatively high price and a relatively low quantity. This is with the assumption that the monopoly is not regulated. With perfect competition, or a market which is characterized by perfect competition, the price will be the lowest and the quantity under perfect competition will be the maximum. With the Cournot assumption, with a duopoly, the price and quantity would lie somewhere in between the monopoly equilibrium and the perfect competition equilibrium point. However, it can be shown that as the number of firms increases, so here we have 2, but as this number increases to 3, 4, 5, 6, etc., then the equilibrium point moves closer and closer to the perfect competition point. Here I'll make a general remark. The curriculum gives formulas and equations and provides a lot of detail to explain this particular material. If you have time, you can go through the explanation. It is long but not very complicated. However, I think that the probability of being tested on the details of the Cournot assumption are relatively low. It is more important that you understand the basic points given over here. And the reason I say that the probability of being tested is relatively low is if you think about where we are talking about market structure. Within market structure, there are several different structures, one of which is an oligopoly. Within oligopoly, we are talking about demand analysis. Within demand analysis, there are different pricing strategies that we are talking about, such as pricing interdependence, the Cournot assumption, and we'll talk about Nash equilibrium on the next slide. And then here we are talking about the details of the Cournot assumption. And I just think that the chances of being tested at this level of detail are relatively low. Nevertheless, if you want to be diligent, go through the numbers in the curriculum. Now we look at Nash equilibrium in a duopoly market. And here is the premise. Notice that with all these assumptions or models, there is a core premise and you need to be on top of that premise. According to the Nash equilibrium, firms arrive at an equilibrium strategy after considering the actions of other firms, and this is called interdependence. There is no incentive for any firm to deviate from the Nash equilibrium. So that's why it's called an equilibrium. Once we are at this equilibrium, firms will stay there because there is no incentive to move out of this equilibrium. We also assume that firms do not cooperate. In other words, there is no collusion. As a general point, this whole concept of Nash equilibrium and how we arrive at Nash equilibrium is a subset of what is called game theory, where we use various tools and techniques that involve evaluating the response of competitors to our behavior. Let us understand Nash equilibrium through an example. Say we have two companies, Wesco and Rifco. They sell a similar product. Now, each company can employ one of two strategies, either a high price strategy or a low price strategy. And the profit for each strategy is shown in this matrix over here. The question is, what is the Nash equilibrium? So of these four boxes, let's say this is box 1, box 2, box 3 and box 4. Where will we end up such that there is no incentive to get out of that particular box? And just to make sure you understand what we are talking about, if we take box 1, in box 1, Wesco follows a low price strategy. Rifco follows a low price strategy also. And if both companies follow a low price strategy, then the profit for Wesco is 50 and the profit for Rifco is 70. And the same explanation can be given for all these other numbers. At any given point in time, we can only be in one of these boxes. It's not possible that we say that for Wesco we are in this box and for Rifco we are in this box. That would not be possible. At one point in time we are in only one box. Now, if you are working as a group, here is what I would suggest. You split into two subgroups. One group can be Wesco, the other group can be Rifco, and you decide which box you will end up in. And remember, each party is looking out for its own best interest. So everyone wants to maximize their revenue, but they also recognize the fact that the other company will respond based on what you do. So spend some time on this before listening to the answer. Now here is what you will end up with. No matter where you start, you will end up in box 4. And let's see why. Let's say we start over here in box 1, Wesco 50, Rifco 70. Now what will Wesco say when they are in this particular box? They will say that they will increase their price, and if they increase their price, their profits jump up from 50 to 300. Wesco also thinks about what Rifco will do if Wesco increases prices, and notice that the profit for Rifco will also increase. So Rifco will not be unhappy, or in fact Rifco will actually be happy if Wesco increases prices. So clearly it makes sense that if for some reason the two companies start out at 1, they will move to box 4. Now what if for some reason both companies started out with a high price strategy, so box 3? In this particular case, Wesco is quite happy because Wesco has a profit of 500, so Wesco will not want to change. But what about Rifco? Rifco realizes that by reducing their price, they can actually increase their profit. So Rifco again is looking out for its best interest, so it's going to change its price to low price. Wesco will maintain high price, and we will end up again in box 4. So notice, no matter where you start, you will end up in this particular box, and that is the Nash equilibrium with these assumptions. The question now is, can both companies be better off if they collude? And the answer clearly seems to be yes, because if you look at the overall industry profit, and the industry here is characterized by these two companies, we have a duopoly, the overall industry profit of 800 is clearly maximum over here versus the next best scenario for the industry, which is 650 over here. Now if Wesco and Rifco decide to collude, how would they be better off? Wesco and Rifco could decide to both set high prices. The total industry profit would then be 800, and if they agree that they split the 800 and Wesco gets 400, Rifco gets 400, note that both companies are better off relative to the Nash equilibrium. Nash equilibrium would have been 300 and 350, so both companies do better in this particular scenario. So there is a benefit to colluding. Colluding, however, might violate antitrust laws, so it might not be legal, but nevertheless profits can be increased here by collusion. According to the curriculum, here are the factors that affect chances of successful collusion, and I suggest you learn these 6 factors. The number and size of sellers, this is fairly intuitive. If we have few sellers, for example only 2 over here, then it is easy to collude. Also, if we have one dominant player, then collusion becomes easier. If products are similar, then collusion is easier relative to a situation where products are not that similar. If the cost structure is similar, then the chances of collusion become more. Order size and frequency. Successful collusion is more likely when orders are frequent and they are received on a regular basis and they are relatively small. Collusion is more likely to be successful if the threat of retaliation is high. And finally, if the degree of external competition is high, then it is more likely that the collusion will be successful. Coming now to supply analysis in oligopoly markets. As with monopolistic competition, the supply function is not well defined. We cannot determine the output and price without considering the demand function. But note that as with all other market structures, profit is maximized when marginal revenue is equal to marginal cost. So this drives the quantity that is produced. The quantity produced must be such that marginal revenue equals marginal cost. That maximizes profit. What then should be the equilibrium price? The equilibrium price is based on the demand curve. Let us consider an example. Say we have an oligopoly market where one firm has significantly lower cost of production relative to its competitors. And let's say that this firm, which is sometimes called the leader or the dominant firm, has 40% market share. The definition of a leader or the dominant firm is one which has lower cost of production compared to the competitors and where the market share is at least 40%. This is one type of an oligopoly market and it is called the dominant firm oligopoly market. In this particular market, we have the dominant firm and let's say that we have 5 other players. The question now is what quantity will be supplied by the market leader or the dominant firm and at what price, and then what quantity will be supplied by the other firms. Let's say that we have price on the y-axis, quantity on the x-axis, and say this is the total demand curve, the demand curve for the overall industry. What about the demand curve for the leader? This dashed line is the demand curve for the dominant firm or the leader. Let's say that this is the marginal revenue curve for the leader, and by now you should have realized that the marginal revenue curve will be downward sloping and steeper than the regular demand curve. This red line over here is the marginal cost curve for the leader. So the profit maximizing quantity is given by Q star. Q star is the profit maximizing quantity for the leader. And the price that will be charged by the leader is going to be this price over here. So price leader. And this is the quantity that will be produced by the leader. The overall quantity which is demanded at this price is given by the demand curve. The assumption over here is that these other 5 firms will simply take the price that is established by the leader, and if they do that, then the overall industry demand is given by this value over here, so quantity demanded by the industry, and the other 5 players will supply this much amount. The leader is supplying this particular quantity. The question now is, why might the other 5 firms not cut price? And the answer is most probably because the leader is the low cost producer and the other firms, which are smaller firms, do not want to get into a price war with the leader. If they do get into a price war, then the leader is likely to win and the smaller firms which have a higher cost structure are likely to lose. Notice that the demand curve for the industry and the demand curve for the leader are not parallel. So the distance between the two curves over here at high prices is substantial, but as prices decrease, the difference becomes much less. Why is this? The answer is that the leader is the low-cost producer. When prices start falling, the smaller players will probably not be able to compete and will exit the industry. So as prices start decreasing, the market share of the leader keeps increasing. And that is reflected by the fact that the difference at this low price between the demand fulfilled by the leader and the overall demand becomes less and less. And again, that is because smaller, less competitive firms or firms with higher cost structures exit the industry, and most of the industry demand then is picked up by the leader. Recognize that over here we've done the supply analysis for only one type of oligopoly, the dominant firm oligopoly, and that's all you really need to focus on because that is what is described in the curriculum. Sections 5.3 and 5.4 are very short. 5.3 deals with optimal price and output. 5.4 talks about factors affecting long-run equilibrium. Here are the two major items that you need to be on top of. There is no single optimum price and output model which works for all oligopoly market situations. As you might have realized, there can be many different kinds of oligopolies. We can have the dominant firm oligopoly. We can have a duopoly where there are essentially two players. You can have three firms in an oligopoly, and then the strategies that are being used by the firms might be different. So we cannot use one single model to come up with the optimum price and output. However, if we look at long-run profits, it is possible that in the long run firms earn economic profits, but when we look at empirical evidence, we look at data over the last several years, it seems to be that over time the market share of dominant firms does decline. So we move slowly towards the prices and quantities that would hold in a perfectly competitive market.